Welcome to this video that discusses the features present in the uncertain variable dialog in Analytics Solver platform. Here's our same simulation example that includes an uncertain variable in cell E13. However, rather than displaying the PSI triangular distribution, I've changed the formula to use the PSI normal distribution in order to show off the use of alternate parameters along with cutoff and sensor values. A PDF chart will appear if you hover over the uncertain variable cell with the mouse. Double-click this cell to open the uncertain variable dialog. Two red lines denote where 90% of the trial values occur. We can easily change these percentages by moving the sliders to the left and to the right as needed. Click the CDF tab to view the cumulative distribution function chart, which displays a running total of the PDF and answers the question, how many trial values fall within a certain class or lower? The reverse CDF chart displays all values greater than the lower class boundary of a given class and answers the question, how many observations fall within a certain class or higher? Here we see the cell address where the uncertain variable resides, the formula inside the cell, and the distribution type. Some distributions can be entered in an alternate form, meaning that rather than using parameters such as the mean and standard deviation to define a distribution, which is what I've done here, a user could specify the distribution using the 10th and 90th percentiles. Scrolling down, we come to our control parameters. Here we can enter a name, such as selling price. We can lock the uncertain variable to a specific value, such as 10. We could enter a seed value, which would ensure that the same trial values are used each time a simulation is ran. We could also enter a shift value, which will shift the distribution to the left or to the right, depending on the value. Analytics Solver platform supports both cutoff bounds and sensor bounds. When you use cutoff bounds, random samples from the distribution are rescaled to lie within the lower and upper bounds. For example, we could use 6 for a lower cutoff and 14 for an upper cutoff. Here you see our rescaled distribution. Now let's eliminate these two cutoff values and instead use our sensor bounds of 6 and 14. When you use a sensor bound, random samples from the distribution that lie above the upper bound are set equal to the upper bound, and samples that lie below the lower bound are set equal to the lower bound. This causes a buildup of probability mass at the bounds, which can be appropriate in some situations, but not in others. Select Statistics from the drop-down menu to display the uncertain variables' associated statistic values, such as mean, standard deviation, variance, and so on. Select Percentiles from the drop-down menu to view the distribution's percentiles. Percentiles give us the probability that a value will be lower than the percentile value. For example, there is a 10% chance that the value for the selling price uncertain variable will be below $7.44. Select Marker from the drop-down menu to create a variety of chart markers to mark and annotate points of interest in the distribution, such as the mean or median value. To add a marker, click the double plus, choose median for the type, and enter median for the description. A black line appears defining the median value for the distribution, which is 10. Select Chart Type to change the type of chart, the color, whether or not grid lines are present, and to add special effects such as 3D and transparency. Finally, select Axis options to change the scale of the X and Y axis. You can choose to apply these changes to this chart only, all charts in the worksheet, or all charts in the workbook by selecting the appropriate radio button, then clicking Save. This concludes this video on Analytics Solver Platform's Uncertain Function Dialog. To contact our technical support staff, click the link that appears on the screen now.